वेरी वेरी गुड आफ्टरनून टू वन एंड ऑल। नमस्कार दोस्तों, स्वागत है आप सभी का स्टडी आईक्यू में। आई होप ऑल ऑफ यू आर कनेक्टेड वेल। सो गाइज, वी आर गोइंग टू स्टार्ट द केमिस्ट्री एंड we will be discussing about the basics of chemistry and in fact some basic terminologies, some basic techniques that we will be talking about. And on Sunday also we will conduct one extra lecture, and that one extra lecture will be covering up the remaining topics of physics, particularly as I had done in the previous batch also. So in that particular one extra lecture, we will be talking about the optics and particularly not optics, waves and electromagnetism and some modern physics we will be talking about. However, in today's class, yes, Shantanu, this Sunday itself. However, in this class, today we are going to discuss some basic chemistry related topics. Let me tell you very clearly that we are not going to talk about the typical chemistry topics such as the physical chemistry or organic chemistry or something like that. We will not segregate it because chemistry is hardly asked in the examination. However, certain terminologies or certain methods, some specifications, they are the favorites of the one-day exams. Particularly the IB also follows the same kind of module, and hence, for example, let me give you a brief intro and this topic which we are going to cover here. Let me tell you, just one second. You can see this one. So the topics which are included here, those include which one? Like, for example, what is a matter, the different physical stages of the matter, okay, then interconversion of the different phases of the matter. Thereafter, we have the new states of matter like plasma and Bose-Einstein condensate, etc. Then we will have the substances and the mixtures. Okay, so basically, what are the elements and compounds, and how are these elements and compounds converted into the mixtures, alloys? How many types of mixtures are there? Got it? Such kind of things we will discuss. And separation of the matter, how does it define into the substance or element or alloy, whatever is there. Then guys, apart from that, we will talk about certain indicators. Indicators are a very favorite in all the one-day exams, including the Intelligence Bureau as well. So these are some indicators, natural indicators, basically, which are used to indicate the acids, bases, and salts. Thereafter, we will understand the types of the mixtures. Then we will see the Tyndall effect and all those things. Guys, every single detail, that is the size of the particles, etc., that is also very, very important. So only hand-picked informations, hand-picked topics have been included into the topic of chemistry. Only that is what is required. Okay. For example, you can see the common examples of the colloids. Again, a favorite of the exams. They ask you that which of the following is the example of the aerosol, or suppose they will give something like the jelly. Jelly is the example of which type of colloidal mixture. So they will ask you such type of questions. Okay, such type of questions. Then guys, the separation of the liquid, solids and other things. So separation techniques, particularly chromatography, is very important. So chromatography, the types, etc., we will do it. Then this particular thin layer chromatography, or you can say high performance liquid chromatography. Okay. Then guys, the basic atomic structure, we will talk about that, the different models of the atoms proposed by the different scholars. We don't need to study anything in detail apart from the fact that how many different atomic models were proposed by the different scientists. Okay, so you can see different atomic models proposed by the different scientists. We have an entire table here which will provide you the details. Then guys, electrovalency, covalency, the types of bonds, basic bonds. Okay, then we have the atomic number, mass number. This is again a favorite topic of all the one-day exams, where they give you this kind of questions. You have to find the number of protons, number of neutrons, okay, such kind of things. So this is what we are going to do in today's lecture. Okay. So let's get started now. And matter. What is matter? Guys, as I told you in the previous lectures that when we study the matter from outside, we understand it as physics. When we study the interaction of the matter and the natural elements, we call it as physics. Like pressure on a certain commodity, on a certain item, like the area, like extension, vibration, and compression, suppression, tension. All these things are just physics. Okay, gravitation and all. However, as we all are aware that matter is something that occupies the space and has some mass, has some sort of mass. Okay. Anything that, exactly, Neha, exactly. It must have some sort of mass in order to be called as a matter. Okay. However, when we talk about matter, the natural phenomena or the natural aspects or the physical properties, like what? Certain physical properties like heat, light, luminescence, electricity, sun rays, okay, or any kind of electromagnetic waves, they are not matter. Why? Because they actually don't have the mass component. They don't occupy the space. Okay. However, anything which occupies the space, which has some mass, that becomes a matter. That becomes a matter. Now, guys, when we talk about the matters, they exist in the various forms in the nature. Okay. Various forms include which ones? So three basic forms are there that everybody is aware of. Everybody is aware of, that is liquid, gas, and solid, obviously, or solid, liquid, and gas. Mayank says that, sir, can question be asked on the interference, like what kind of light was it used? Mayank ji, you may expect. See, I will always tell you that there has to be some intelligent, orientation towards the examination. Seeing the questions which are asked in the previous year exam, I don't think they would be asking such kind of questions. But if they ask it, we cannot blame it. But we must not be emphasizing that they would be asking such kind of questions. Guys, I just also I wanted to tell you all that apart from the class that we are doing or class notes that we are having, I will be giving you some pages, like 4 or 5 pages, not much, which will be having the information about the important scientific instruments. Okay, important scientific instruments, important scientific discoveries and inventions. So these instruments which are used in the various kinds of measurements and the various kinds of studies, plus the important discoveries and inventions in science, important theories, and who were the proponents of those theories, inventions, and discoveries. Because I observed one thing, that they have asked a couple of questions on this line as well. Okay. And that's a very, I would say, easier thing to do, at least before the examination. All right. Because these type of questions are very difficult to tackle in the regular classes, because they don't require any kind of classroom preparation. They require just the self study, and that is what we can actually arrange for you guys, so that you can do that. Now, guys, three stages of the matter, or three phases of the matter. Primarily, solid, if it is melted, it's called as fusion. Then it becomes liquid. Thereafter, we have liquid when it vaporizes. When it vaporizes, it vaporizes into the gas. This process is called as the vaporization. Then guys, this gas, it converts into solid. Gas converting into solid is called as the deposition of gases. The deposition of gases. Prathamesh, don't leave any pages. Don't leave any pages. Right. So these are the three basic steps of the phase conversion, and we have to learn these three basic phases of the step conversion, right? Three basic steps of the phase conversion. So let us define each of them. Okay, let us define each of them. And here, all right. So what is fusion or melting? Fusion or melting, basically the bonds of molecules become loose, and there comes fluidity in the matter. Okay, it is called fusion. It's called fusion. Got it, everyone? For Sunday, do we need to leave? No. Don't leave pages in advance. Just keep that. If you are noting down the physics, chemistry, and everything in the same, then you can leave a few pages, like 10 pages, 8 to 10 pages, max to max. Okay. Guys, fusion or melting is something where if you provide the energy, okay, in the form of heat, when you provide the heat as the energy, and that results into the bonds of molecules becoming loose and the fluidity comes into the picture, then it becomes the process of melting or the process of fusion. Are you able to get the point? However, when we understand the vaporization, so what is that? So upon the further heating, the fluid or the liquid starts breaking out its bonds, and the molecules start gasifying. Okay, they start gasifying. Got it, everyone? And the gasification is basically called as the vaporization, and it occurs in at a specific temperature, and this occurs at a specific temperature itself. Okay, actually both of them have their own specific temperature. You cannot vaporize any particular component or any particular thing at any particular temperature. You cannot do that. For each and every material, for each and every matter, we have a very specific boiling point, we have a very specific melting point. Are you getting the thing here? So iron has a different melting point, aluminum has a different melting point, plastic has a different melting point, different types of plastic have different types of melting points. Okay, so each of the points are very fixed in the temperature value. Then guys, deposition. So what happens? The gases are converted into solids directly or indirectly. Directly or indirectly. Then we call it as the, or say due to suppose thundering, biotic factors, etc. It's called deposition. Okay, everybody. So deposition is basically what? It is similar to condensation, right? Similar to condensation. Guys, in case of condensation, what happens that the gases are condensed, and we all are aware that gases, basically, what are the gases? They are actually the high energy level molecules which are moving away from each other because of the high energy status, means high temperature. But when you reduce the temperature, that reduces the energy level of each molecules in the gases, and the reducing energy level of the molecules bring them closer together, and eventually they convert into the liquid. So the gases converting into the liquid, that is your condensation. But my dear, in certain cases, what happens that the gases get converted into the solids. For example, have you seen the lamp black? The lamp black, yes, lamp black or the kajal, what is that? It is a kind of solid which is the result of the deposition of the gases. Basically, when you burn something, when you burn some special kind of preparation of the oil and other things, so that results into the formation of the flue gases containing the heavier carbon molecules and all, isn't it? So there, if you just let those gases hit the surface, you would see that the gas is getting deposited into the pores of the special kind of pot. The pore of the pottery actually traps those gases, and particularly the solid form of that is obtained. Apart from that, you also have the nitrogen solidification, or say nitrogen deposition, done by the several group of bacteria in the plants, particularly the nodules of the leguminous plants. Okay, so guys, this is how you get to see the deposition, vaporization, and fusion. Got it? Now guys, apart from that, you have three more terminologies here, including number one, that is when we say liquid to solid, solid to gas, and gas to liquid. The reverse of this cycle actually gives you three more terms. What are those three terms? Number one, condensation. condensation is basically the change of phase from vapor or say gases to liquid. So gases to liquid, okay, that is called as the condensation, okay. And here the energy means heat is lost, resulting into the molecules coming closer together. Okay. Example, petroleum gas to LPG. Okay. Energy or pressure. Okay. So guys, condensation is possible in two different manners. Number one, either you provide the heat, you extract the heat out of it, means you take out the heat, it becomes liquid. Like in case of the rainwater, the heat is taken out of the evaporated water and then it converts into the liquid, isn't it? Or say the condensation of the steam leads to the formation of the water. However, you can also create the process of condensation by providing the high pressure to a gas. So guys, that is actually called as the compression, and we can say that gases are compressible. Gases are compressible, okay. So they, under the compression, they are condensated. They are condensated. Okay. So if we talk about proper technique, then it is the heat which we extract from the system, then it becomes condensation. Otherwise, you can also provide the condensation like effect, which is called compression, by increasing the pressure on the gas. Okay, remember that. So pressure and temperature both play the role in condensation separately. Okay, now guys, evaporated water to rainwater. This is condensation. Okay, then we have sublimation. What is sublimation, my dear? Sublimation is basically when the change of phase from solid to gas without, yeah, we can simplify it directly. Okay, everyone. So when you don't convert the solid into liquid, but that solid is directly converted into the gas, then it is called as sublimation. It is called as sublimation. So there are several examples of sublimation, but the best ones are basically those naphthalene balls or the camphor, those things actually convert, or they simply turn the solid into gases without even getting into the liquid state. Okay, so example, okay, naphthalene balls. Then guys, we have solidification. Which is also called as the freezing, solidification or freezing. So it's pretty simple, that is change of liquid into solid. याद रखना कि प्रेशर का काम यहां पर नहीं रहता है, हालांकि जो है वो प्रेशर कभी कभी रोल प्ले कर सकता है, बट the pressure is something which is only working upon gases, and because the gases are compressible, right? The water or say any liquid is not compressible. Got it? Water to ice cubes, yes, definitely water to ice cubes. Now guys, actually what happens that when we talk about the solidification is usually obtained in the liquids only as the result of the reduced temperature. Remember that, because they ask the questions that which of the following is a non-compressible fluid. Non-compressible fluid means the liquids. Gases are compressible fluids. Okay everyone, I hope you all got that point, right? Now if we talk about one more thing, right, one more thing, even though we had discussed about it in the physics class as well, guys, latent heat. Do you remember what was the latent heat? Latent heat was that hidden heat which was responsible only to change the phase without changing the temperature. That was called as the latent heat of fusion, latent heat of sublimation, latent heat of evaporation, latent heat of vaporization. Okay, it simply changes the phase of one matter to the another matter, but does not increase the temperature of that matter. All right. Burning of candles come under what? Burning of candles, actually the candles, they do melt. And if you particularly say candle, so they actually melt and become liquid as well. However, the molten wax of that candle actually solidifies very quickly. So burning of candle actually comes under the, that you can say, typical melting or typical heat of fusion, solid to liquid fusion. Okay, the it does not convert into the gas directly. Okay, Sadvik, the candles don't convert directly into the gas. You have seen that, you must have seen that, those molten wax actually, that molten wax actually flows on the candle itself and just gets deposited. So in fact, solidification, the best example of solidification is actually the molten wax on the candlestick becomes solidified as soon as it goes down. That is molten. When it is released, it is molten, completely liquid. But as it dries up very quickly and solidifies very quickly. Okay, very quickly. So guys, the special heat, let me tell you, the special heat responsible for phase change is latent heat. Okay, latent heat. Got it? So there you can see, there you can see. Yes, exactly, Mayank, exactly. So guys, now let us understand the two more states of matter. So what are those two more states of matter? Wait a minute. Two more states of matter include the plasma and Bose-Einstein condensate. Now, what is the meaning of these two? Let us understand. What is plasma? Guys, plasma is actually the mixture of, the mixture of, I would say, electrons and ions, free electrons and ions. Okay. Basically, what happens that when a gaseous stage, is mixed up with the free electrons and ions, then it becomes plasma state. Gaseous state is mixed with the free electrons and ions. Okay. So guys, here you can see the gases at very, very low pressure, when the electricity is passed through such kind of gases which are entrapped in a glass tube, there we see the plasma generation. Okay, plasma generation. Got it? So guys, have you seen those special effects where within a glass tube the current is passed through and then you just see some sparkling and some zigzag kind of shine, and then after some time it just booms. So that particular state before the popping up of that glass tube, that particular stage is called as the plasma state. In the nature we have maximum entities in the plasma state. Sun is in the plasma state only. The sun is in the plasma state only. Okay, remember that. So this plasma actually makes through, right, it makes the glowing effect as well. Anyways, so Bose-Einstein condensate, what is that? Guys, the Bose-Einstein condensate, yes, exactly, Sadhvik, kind of. Bose-Einstein condensate is actually that special kind of state of matter where, at a very, very, very low temperature and extremely low density of the gases, okay, then we obtain the BEC or Bose-Einstein condensate. Is thundering plasma, Mayank, thundering through the clouds creates the plasma for a while. Okay, thundering through the clouds creates plasma for a while. It is believed that thundering actually dispels the huge amount of the charges, and the clouds, they carry those charges as well. Sometimes they are having that split because of it. Okay. Anyways, so guys, did you all understand the plasma state and the Bose-Einstein condensate state? What is this Bose-Einstein condensate? When a gas of a very low density is cooled to the extremely low temperature, there we obtain a different kind of stage of the nature where the matters behave differently. Okay, remember. Now solve it, everyone. Solve it. Solve it, everybody. Which of the following statements about the factors affecting the evaporation is not correct? The surface area is increased, the rate of evaporation increases. Increase in the wind speed decreases the rate of evaporation. Amount of the water in the air is directly already high, the rate of evaporation decreases. Increase of temperature increases the rate of evaporation. Yes, everyone. B is wrong, B is wrong, B is wrong. Very good. So I think all of you got the answer. The increase in the wind speed decreases the rate of evaporation is wrong. Okay, that is wrong. All right. Rest everything is correct. Absolutely easy question. So guys, since we talked about the different phases of the matters, let me have some water. All right. So we were talking about the different phases of the matters. Now let us assume that these matters which are available in the different phases, what are the nature or what are the natural characteristics of those matters? Like, are they the pure substances or are they the impure substances? How many of those matters or substances are elements? How many of those are compounds or mixtures? How can we separate them out if they are mixed with each other, right? Such kind of things basically we are going to study now. So when we talk about the substances, pure substances and mixtures, here let me tell you guys, usually a pure substance is basically the one kind of particle. It is a one specific kind of particle that may be a molecule, that may be an atom, but only one kind of atom or only one kind of molecule. For example, gold. Gold is a pure substance. Only gold is there, one kind of atom, isn't it? Carbon, only one kind of atom. Diamond, of course, one kind of atom, isn't it? Guys, I hope you got the point here. Carbon is having just one kind of atom, only carbon. Silicon, one kind of atom, only silicon. But now tell me, is the water a pure substance? Is the water a pure substance? But before telling, just read. Okay, just read. Prathamesh says, please repeat, not clear. What not clear, my dear? I'm telling you that something which is made up of only one kind of particle, in which each and every particle, each and every constituent particle of that particular matter or that particular substance, that behaves as a very same thing, right? So if we take the example of the water, so guys, can you say that water in its natural condition behaves differently? Like H2O, if you are taking the water off the tap, that will be different, and H2O, if you take the water of the mountains, that will be different. Is it happening like that? No, it is not happening like that. So water is a pure substance. Water is a pure substance. Remember that. Water is a pure substance. Why is water the pure substance? Because water is a kind of compound, and we all must understand that compound is something different from the element. Even though there are two or more elements in one compound, but the properties of the compound, they don't match to the properties of the element. They are completely different. Okay, they are completely different. This is why, my dear, this is why the compounds and the elements are both important and pure matters. Important and pure matters. Okay, everybody. So I hope that all of you understood the point. All right. Now, so if the source is not specified, is the water pure? Usually it is regarded as the pure because it is assumed that water is not polluted. It is assumed that water is not polluted. So usually if you have the source specified, it means that they are expecting the polluted water or some special kind of water like sea water, etc. Otherwise, in general, the pure water is pure substance. The pure water is pure substance. The sea water is not a pure substance. And why so? Because sea water is something which contains a lot of extra halides. Okay. And it means that it is not pure at all, because there is something else also other than H2O, and that is at the chemical level we are talking about, right? Now, chemical level. Got it? Sir, water minerals have minerals in Mehak ji. I told you the pure water is the pure substance. Pure water is pure substance, means H2O is the pure substance, not some H2O mixed with the copper, lead, arsenic, all these things. They don't matter. All right, everyone, did you all understand? Right. So, guys, as we discussed that, two types of matters or pure substances are there. Okay, here are those two: elements and compounds. Okay, elements and compounds. In each of them, let me tell you, elements actually they have one single kind of atoms, right? One single kind of atoms. Whereas if we talk about compound, okay, in compound we have you can say different kinds of particles, different kinds of backgrounds and all. So what happened here, the two or more substances actually embrace or mix, and then the next, right, what happened, that they carry their own identity. So that is basically what, that is basically two types of that is elements and compounds. Okay. However, guys, uh, in case of any such particles, any such kind of particles, which basically are repeated multiple times and they make something very similar, they are elements. Remember that. So, guys, if we talk about elements and compounds, they could be, they particularly compounds, if we talk about, they could be homogeneous compound or heterogeneous compound. What is the meaning of the compound? Okay. So, guys, the homogeneous and heterogeneous, right? Homogeneous means absolutely similar, right? Absolutely similar. That means exactly same as that. So, guys, the homogeneous and heterogeneous, if we talk about, they are the types of the mixtures, because the compounds are always homogeneous only, always homogeneous only. Okay. Now, so guys, we understood the mixture and all that, but just a second, guys, just a second, I'm having a little bit of cough. Okay, 1 minute, give me 1 minute, I'll be back from the washroom. All right, everyone. So now let us talk about the matter, and with the help of this particular graph, you can clearly see that if the matter can be physically separated, then it is mixture. If it is not possible to separate it physically, then it is a pure substance. Okay, so can you physically separate this particular thing? Now let me tell you, this plastic, this is the plastic which is made of the hydrogen and carbon atoms. Okay, so can you separate the hydrogen and carbon by heating this, or by drying this, or by crushing this? Mahak ji, come on, you are saying yes. You cannot. You cannot separate the hydrogen and carbon by just heating this plastic. You cannot do that. It will melt and it will again deposit. It will melt and again it will solidify. It will not give you the separate hydrogen and carbon anyhow. Anyhow. So this is a compound. Plastic is a compound only, na? Suppose, let me tell you, suppose, so right, this is the kada. Okay, this is the kada that we wear, right? This kada is actually what? It is a steel. Got it? Steel is a compound. This cloth, it is a compound. So can you simply heat that cloth like doing the press, or can you just twist that cloth by applying pressure, or can you just put that cloth in the light by applying the light? Any kind of physical activities, any kind of physical methods, can you separate it? No, you cannot take the carbon or hydrogen or oxygen out of this cloth just by twisting, stretching, pulling, pushing, forcing. Not possible. So guys, if you cannot separate it physically, okay, if you cannot separate it physically, it is the pure substance. It is the pure substance. Okay, everyone? And even if it is the pure substance, now let us check whether it is element or compound. So what do you need to understand? Can it be chemically decomposed? Which means that, can you break down this particular element, or this particular matter by the chemical methods even further? Like, can you break this particular matter into the simpler form of the matters by the chemical process? Right, you can do that, na? This is the cloth. By using the chemical process, you can actually change, literally you can change the, or say obtain the carbon, nitrogen, oxygen, whatever is there, you can simply get it differentiated with the help of the chemical, So when you chemically decompose, you are able to decompose any substance, then it means that the substance which you have, that is a compound. That is a compound. Mahak ji is saying that is why I said yes, hydrogen and Mahak ji, I'm not saying that they cannot be separated. I told you that they cannot be separated physically with the help of the physical activity, with the help of like beating the water, pushing the water, pulling the water, forcing the water, pressurizing the water. You cannot separate the hydrogen and oxygen from that process. You can only do that by the electrolysis or by some other chemical process. So that is the condition. So when you can break down that matter into the simpler matters with the help of the chemical activity, you call that matter as compound, like carbon dioxide, methane, water, then anything, boric acid, hydrochloric acid, anything. However, it is possible only for compounds, but my dear, some of the things are there, some of the matters are there where you cannot break it chemically any further. Like, you cannot break calcium or oxygen by breaking it chemically. No, it will remain oxygen only. It will remain, anything that is there. Got it? So which means that hydrogen, helium, carbon, nitrogen, oxygen, etc., fluorine, etc., they cannot be called as the compounds, but they are the elements, because they cannot be broken down further into any more simpler matters. Okay. You can break the carbohydrates into the glucose. You can break the glucose into carbon and hydrogen, but you cannot break carbon into something, or hydrogen into something, or oxygen into something. You cannot break that. Okay, everyone? Okay, I hope you got the point. So these are the pure substances. Now talking about the impure substances. So if the matter is physically separable, then that is a mixture. That is a mixture. That is not a compound. However, in a mixture, if the composition of the mixture is uniform, that means bilkul similar, right? Same to same. So it is uniform. Then we have what? We have the homogeneous mixture and heterogeneous mixture. Okay. What is the meaning of the homogeneous mixture and heterogeneous mixture? Homogeneous mixtures means what? Homogeneous mixtures means if you take any sample, any kind of sample from that random place, usually you obtain the exactly same structure of or same composition of the matters into that mixture. Like for example, if you see this one, guys, air is a mixture. Air is a mixture, right? So when you have that air, any kind of air, usually you have the same percentage of nitrogen, oxygen, carbon dioxide, and some other gases, isn't it? Same. So there is literally no difference. Like example, okay, blood. If you take the blood of hands, blood of belly, blood of feet, everywhere the blood will give you similar kind of structural report, similar kind of orientation. Okay. Then guys, heterogeneous mixture, what is that? Okay. So heterogeneous mixture, if we talk about, guys, these are the mixtures where you can say the mixture is not uniform in the nature. It means that, for example, the colloids or the suspensions, okay, these are the best examples at the moment. And why so? It is because we all can understand that if you take one particular sample, it may have the rich or it may not have the rich mixtures. Okay, that is why it is the heterogeneous mixture. Example, colloidal, okay, suspensions and all that. So these are the heterogeneous mixtures. Okay. Now, yes, uniform composition. Okay, guys. So now if we talk about the further things, okay, just a minute. So guys, universe, earth crust, and human body. So as per the ratio of occupation of the molecules percentage, not on the basis of mass. Let me specify this, not on the basis of mass. Okay, not on the basis of mass, but on the basis of the total volume. Okay. Now, so guys, as you can observe that the earth crust by volume contains oxygen as the maximum percentage, and the human body contains hydrogen as the maximum percentage. Universe also contains hydrogen anyways. So guys, now if we understand that elements have the pure substances, we had the, you know, after that compound and compound and element, etc. Then what is this compound here which is written here? So guys, substance that can be broken down into two or more simpler substances by the chemical means. Okay, remember that. So if we do some chemical process and we can break one big compound, say for example starch, into a smaller compound, say for example glucose, then we call it as the, it is visible. Okay, actually today I have already taken like almost 4 hours 5 hours of classes at this moment, and it's very difficult, right, to continuously stand for 5 hours 6 hours kind of things. I hope you won't mind me sitting for a while. Okay, now guys, we understood that what is a compound basically. So compound is, now we understood that they are very 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 useful things. However, the compounds, the compounds, if we talk about, they actually lead to the possibility of breaking down, breaking down, and that is something which makes it very useful, very very useful. Okay, so guys, there are certain compounds which are very useful compounds as far as the utility is concerned. Like for example, we have several compounds in the daily life, like plaster of Paris is there, like cement is there, like petroleum is there. Okay, all these things we have as the compounds. Okay, and particularly if we talk about compounds right now, guys, the compounds actually have the different natures as well. Some of them are like elements also, compounds also. Some of them are acidic in the nature, some of them are the basic, and some others are neutral, of course. Now if we talk about them, so here we use the indicators. Okay, those indicators tell you the conditions of your different acids or the bases and all that. So in India also, if you talk about, the indicators are used heavily, which are a dye, the coastline, right? If you talk about the dyes, these dyes actually provide you the different colors and all that. Anyways, so colors, right? Here guys, let me tell you that litmus, very very famous. I think everybody must be aware about the litmus, blue litmus, red litmus, right? After that, just a second, after that, methyl orange, phenolphthalein. But guys, some other natural elements are also there, like you can see here, vanilla, onion, okay, then turmeric, red cabbage juice, right? So these things are also used as the indicators, okay, remember that. There was a question which was asked that litmus is made from, and a lichen, okay, a lichen. Okay guys, so mixture and compound, the differences are noted down in the table. You can just read it for your revision purpose. Now, types of mixtures, we understood the types of mixtures are, there are basically different types of mixtures. We had the homogeneous mixtures and heterogeneous mixtures, if you remember that guys. Homogeneous and heterogeneous, right? Homogeneous and heterogeneous. Okay, so when we talk about the homogeneous mixture, we have solutions, we have solutions. So solutions are homogeneous mixtures. Remember that. Homogeneous mixtures means basically they have absolutely dissolved solute into a liquid called solvent. Solute, solvent, solution. Okay, solute is that powder, sugar, salt, etc. Solvent is that water, and sugar plus water, if you just dissolve it, the sugar is absolutely dissolved. It is not visible from the naked eyes. Not visible from the naked eyes. Okay, if you pass the light through the solution, it simply passes through. It simply passes through. It means that the particles are so tiny that they can't even obstruct the light. Can't even obstruct the light. Okay, so it means that the solutions are homogeneous in nature. After that, my dear, after that, if we talk about the solutions different category, so guys, the solutions could be, they could be concentrated, dilute, or saturated. Three different names are there: concentrated, dilute, and saturated. Meaning of concentrated means what? Means the solute is high in percentage than the regular solution. So that is concentrated. Then we had no, dilute. What is that? Dilute is when the solute is very less, and therefore the solvent, it is not much affected. It is the we can say dilute solution. After dilute solution or concentrated solution, we have the saturated solution. Saturated solution is the extreme kind of concentrated solution. Means that if you keep on adding the sugar in a water glass, after some times the sugar stops dissolving. Are you okay with that? Everybody knows. But if you further keep on heating it, if you keep heating it, it again, what happens? Again starts dissolving. But after some time, despite heating it, no more sugar is possible to be dissolved in this particular water. Otherwise, the entire water will be converted. It is already converted into the sugar solution. It will be crystallizing. It will be crystallizing. So guys, we can say that the concentrated, dilute, or saturated, whatever may be the type of solution, that does not actually matter much, apart from the thing that the concentration of a solution is the amount or the mass of volume of the solute present in a given amount of solution. Okay, so basically the amount of solute in the given amount of solution, or solvent. Okay, then guys, we understood the three different types: concentrated, dilute, and saturated. Saturated means no more intake is possible. Okay, just a minute. After that, we have the different types of mixtures, which are basically the heterogeneous mixtures like suspension. Now, what is a suspension, my dear? Suspension is something where the larger or the bigger particles are tried to be dissolved into a liquid solvent. A liquid solvent. So here they are spreaded throughout the medium liquid. And guys, sometimes, for example, if you take this much of water, and if you pour 1 teaspoon of the glucon D, the white glucose, and just keep on mixing it up, you would see that the glucon D is disappeared, or sugar, if it is plain sugar or plain salt, it completely disappears. That is solution. However, if you pour, say, 1 teaspoon of soil, mitti, and then you just shake it and try to blend it, you will see that the soil is just running into the water, right? But as soon as you put this bottle on the rest, the water comes to the rest and the soil that also comes to the rest, which means that in the suspension, if you don't frequently move that object, it simply settles down. It simply settles down. Okay, solute settles down. Then guys, colloidal mixture. What is that colloidal mixture? Colloidal mixture is something where you can see due to the smaller particle size compared to suspension, but in reality it is heterogeneous mixture. So guys, colloidal solution actually appear like a homogeneous mixture, but it is a heterogeneous mixture. For example, the particles of colloids are uniformly spread throughout the solution, and the particle size is larger than the solution but smaller than the suspension. Remember that. Okay, larger than the solution but smaller than the suspension. Okay, so that is your colloids. That is your colloids. So if you have to identify, you can see this one. Colloids are basically where the particle size is 1 nanometer to 1000 nanometer, means it is still smaller size than the solution. Okay, and the biggest size that comes in the suspension, because of the big size of molecules only the suspensions actually settle down. Okay, understand it with the examples now. So guys, here let me tell you, there is one dispersed phase. Dispersed phase means what? The phase which is dispersed into some sort of medium. Okay, now that is called dispersion medium. That's called dispersion medium. For example, suppose if I take this particular solid, okay, this particular solid, and thereafter we put some sort of liquid into it, okay, liquid into it, or say solid into it, then we come across what? So if we have the dispersion medium as solid and we put liquid into it, we get gel, right? We get actually gel, not gel, we get gel. Okay, gel, jelly, cheese, butter kind of things. Okay, that is what happens. Similarly, you can see liquid. So dispersion, dispersed phase, and a dispersing medium. That is what we need to understand first. Dispersed phase means, suppose the phase which we are losing out. Okay, that is anything that is basically liquid, solid, gas, liquid, solid. Okay, like that. The main role that comes from the dispersion medium. Okay, dispersing medium means what? Medium means in which medium is it going to be dispersed. That is dispersing medium. Okay, remember that. Answer please, everyone. Answer please. Answer please, everybody. The particles of a suspension can be seen through the naked eyes. Particles of suspension can be seen through the naked eyes. Yes. The particles of suspension scatter a beam of light passing through it and makes its path visible. Okay. And then solution particles settle down when a suspension is left undisturbed. Okay. हाँ जी. So the solute particles settle down when a suspension is left undisturbed. Yes, absolutely correct. The particles of suspension scatter a beam, light passing through it and makes its path visible. Yes, correct. The particles of suspension can be seen through the naked eyes. Yes, correct. Right answer is option number D. Option number D. Now, guys, talking about the separation of the two mixtures. Separation of the two mixtures. Okay. So now let us take a break, small break here. Okay, and it will be 10 minutes. After that, we will be covering up. Okay. Welcome back, everyone. So now let us talk about the separation. So guys, separation is basically with the help of the different methods. When the two solids are there, they are separated with the help of the suitable solvent. Like for example, suppose we have the very fine white particles mixed with the salt particle, then we can actually mix it in the water. The salt will be dissolved and we can actually separate it out. Sublimation, again, salt and camphor, both are white, both are crystalline, and both are crushed. Suppose both of them are mixed together, then we heat it up. The camphor is sublimated, the salt does not, and that remains. Right, everybody? Now, hello, Vinuta, and you can download. How can you download this notes? Okay. In order to download the notes of this class, you can actually go to the class video, and underneath you have that tab of my content. You can open that my content, you can see the video, and just under the video you have that PPT uploaded with it. Okay, so you can download it from there itself. Okay, Vinuta. Now, as far as the mixture of solid and liquid is concerned, then we have different kind of methods, such as the filtration. Guys, the filtration is done with the help of filter paper, or with the help of a filter net. Okay, a filter net. Then we have centrifugation. When we have the impurities, impurities of the varying density, then we use the centrifugation, and the lighter things actually come on the top, and the heavier thing remains downward. That is called centrifugation. Okay, like the skimming of the milk, where the cream is taken out, that is your centrifugation. Okay, then evaporation. Let me just write it down as well. Filtration, use of filter paper, fine cloth. Then guys, centrifugation, example, skimming of milk. Okay, evaporation. Guys, evaporation is very simple thing, right? You can simply just do one thing, like suppose water and salt, they are mixed up, and you want to take the salt out. Just evaporate the water, take the salt out. You get it? Okay. Then guys, crystallization. Now, crystallization is something where we obtain the solute back. Okay. So again, this is just the reverse of the vaporization or evaporation. In the crystallization, what happens that suppose something is molten in a state, you just cool it down, that is crystallized. Okay, the one of the mixture is crystallized, other is not. Okay, like for example, if you see sugar solution, right? Sugar solution, if it's there, so you can crystallize the sugar. By cooling the entire liquid together. Okay, so that is crystallization. Evaporation and crystallization, both of them are used simultaneously to separate the solute and the solvent. Okay, distillation. Guys, distillation is just another type of separation method for solute and solvent, but the priority here is the separation of the solvent. For example, water contains a lot of impurities, but if we want to collect the purest form of the water, then what would we do, right? What would we do? We would be boiling this water and converting it into the steam. Then we would be using that steam, or passing that steam through the cooler areas, and then the steam is cooled down, converted into the liquid, and the liquid is collected. That is the distilled water. And the process of heating, evaporating, and cooling it down is called distillation. Then guys, the distillation also has a variant, fractional distillation. Fractional distillation. What is a fractional distillation, everybody? Suppose a liquid contains different kinds of mixtures, different kinds of liquids or gases or solids together. Each of them have the different boiling points. Then we use a very special container where at every level we have the passages. So after heating the entire solution, suppose something is there which it starts evaporating at just 20 degrees Celsius or 30 degrees Celsius, and that will go on the top at the earliest because it is in the gaseous form and it just goes on the top, hits the top. So separate that chamber and add one pipette, and from that pipette just collect the dots of liquid which we are getting. The drops are a different thing. Thereafter, suppose 50 degrees Celsius, then 100 degrees Celsius, then 200 degrees Celsius kind of. So each interval will have the distinct material which is separated out and which is, I would say, collected. Okay. So guys, this is called as the fractional distillation. Okay. Then we have the chromatography. Now, what is chromatography, guys? Chromatography is something where different substances interact differently with the stationary and mobile phase, and this interaction separates the compounds from one another. Now, what is this? Guys, have you seen that suppose different kinds of pigments are there, and each of the pigment acts differently when it is mixed up with the water or any other solution, or any other solvent. So what would you do? You just drop those pigments into the water, and you would see that one of them is having a long thread, another one is just a small little bit of color is there, the third one is just intact, it's spreading no colors at all. So this is how you separate it out. There are different types of the chromatographic methods. Like for example, you can see paper chromatography, thin layer chromatography, column chromatography, right? These are the different kinds of chromatography methods which are used to differentiate the pigments of different colors dissolved in the water or any other similar liquid medium. Okay, so you can see that, right? You can see this is basically what this is actually the TLC, thin layer, right? Thin layer chromatography plate, TLC plate. Okay, this is the TLC chamber. Now here it is the liquid mixed with the pigments and all. You have just kept that. Okay, everyone. Now this TLC paper or TLC plate, it is dissolved into the water. All right. And you keep on waiting and waiting and waiting. What happens? This is the original sample. Okay, this is the original sample. But my dear, this sample actually contains the different kinds of compounds, and this thin layer plate, it provides a medium of motion to the different compounds, and different compounds of the different colors, they have the different mobility as well. Okay, so you can see that the separation has already started off. And once this is completely separated, you can see this is compound A, this is compound B, this is compound C, and you can also see that the water level was very less, just up to this. Okay, just up to this. But afterwards, you can see the water level is rising up, up, and the color of the TLC is completely changed. Okay. Similarly, the TLC now contains the three distinct compounds located at three distinct places. Now you can use those different places to scratch those compounds of that TLC, and you get your separate compounds, right, collectively. Then guys, we have the high performance liquid chromatography. Now what is that? So guys, this is solvent, this is pump. Okay, this is high performance liquid chromatography column, HPLC column. All right, and this column, it contains what? It contains the chromatographic plate or chromatographic cylinder, right? So what happens? This chromatographic cylinder actually separates the different mixtures or different components of the mixture. You can see one color that starts separating out, then you have the one color, two color properly separated, and after that, whatever waste is excessive, that is collected subsequently. Okay, so this is a more electronic and more mechanized kind of version, right? More mechanized kind of version. What is TLC plate, Shantanu ji? TLC plate is basically thin liquid chromatography. Thin liquid chromatography plate. Okay, thin liquid chromatography plate. I think some of you might have conducted your experiments, etc., in the school time as well. There was an experiment in the TLC related, right? But most of the school labs, they did not have the TLC in that period, right? I hope so they have it now. Then guys, I hope you understood the method of separation, etc., for everything, like for the colloids. No, sorry, separation of colloids is not there. My methods of identification for the colloids and all that. Okay, okay, you did that. That's great. Now let us come to the second topic. Second topic is atomic structure and radioactivity. Atomic structure and radioactivity. So guys, what is that atomic structure and what is the radioactivity here? So guys, if we talk about the atomic structure here, John Dalton, he said that the matters, they have their elementary properties stored in a very tiny particle, a very, very tiny particle, and that particle is called as the metal, particle is called as the atom. Okay, atom. This atom is the smallest particle as per Dalton, and it can exist, it can take part in a chemical reaction. Guys, this was the very, very basic kind of definition which was used not only by Dalton but also in India. There was Kanad, a sage of the Vedic period whose name was Kanad. Okay, and thereafter in Greece also they had a different person. Right. Actually, the Greeks and the Indians or the Egyptians, they all knew about the possibility of a small basic particle with the possibility of containing all the properties of the exact. Now, just a second. All right. Now, if we talk about the different things like laws of chemical combination and all that, so guys, laws of chemical combination, law of chemical combination is basically called, right, into two parts: law of conservation of mass and conservation of constant proportions. So what is that, guys? If we talk about the two laws of the chemical combination, number one includes the conservation of mass, which means that in any kind of chemical reactions, okay, in any kind of chemical reactions, there is absolutely no change or no reduction in the mass, right? So whatever mass is there, that will be remaining conserved, completely conserved, no changes at all. Okay, everyone. And automatically, this mass is now related to the proportion of the substances as well, because you see that mass is dependent upon the atomic number as well, isn't it? Mass is dependent upon the atomic number. And since the number of atoms that we have will remain proportionate constantly in the proportion, that is your second law. That is second law. For example, if you see that, for example, suppose if you have a hydrogen plus oxygen is equal to water, or say carbon plus oxygen is equal to CO2. So guys, now this is something which is very, very fundamental. Here the number of the molecules, number of the atoms on both the sides, they are very much same to same, right? So there is no difference as such. However, these two laws, the conservation of mass and conservation of proportions, okay, these two laws collectively known as the law of chemical combination, and still they are valid because that is how it is used. Okay. Remember that. Now guys, moving further, let us find out the basic definitions of the things like molecules, atoms, ions, etc., etc. Okay, everyone. So what is the meaning of the atom? So guys, atom is something which is the smallest particle which takes part in the chemical reactions and which carries the property, but that is usually not stable. Okay, not stable. All right. So atoms are basically what? Smallest particle take part in but can't stay stable. Okay, so guys, it is very, very unlikely, very, very rare that an atom stays without any kind of reaction. It will do some sort of reaction. It will definitely search or look for some other atom to bond with it, and it will form, either late or later rather than sooner, it will form a molecule. There are very, very, very few such atoms which can stay together or which can stay single, right? But usually the atoms, they exist in the form of combination, like two or more atoms are there, like hydrogen, nitrogen, oxygen, chlorine, etc. They are basically the diatomic, means two atoms together form a molecule. What is molecule? Molecule is basically the group of the two or more atoms bonded together. Okay, bonded together, and As far as existing in the free state is concerned, this is the smallest particle. The molecule is the smallest particle that can exist in the free state. Means even if it is not doing any chemical reaction, it will not get destroyed. Okay, remember that. So molecules are the smallest particles or electrically neutral group, which is basically possible, right? Possible to exist together, because usually they have two atoms. Okay, but there are the atoms which are not possible to exist alone. Now, if we talk about the ion, what are ions? So combined, right, compounds basically formed by combining the metals and non-metals. Okay, so what are the ions? Metallic as well as the non-metallic entities together. Okay, these ions can be single charged atoms or group of atoms carrying a net charge. Guys, come on, very simple. Anything that is an ion which either takes part in the reaction actively or passively. Okay, na? For example, in the constituent particles of the sodium chloride, that is the common salt, they are sodium as well as the chlorine. Common salt, table salt. Answer this question, everyone. Answer this question, everybody. Which of the following statements with reference to the atoms and molecules is not correct? During a chemical reaction, the sum of the masses of the reactants and products remains unchanged. Okay, that is your okay. Answer this question, everyone. Then an atom is the smallest particle of an element and compound capable of independent existence under ordinary conditions. The chemical formula of a metal molecule compound is determined by the valency of each element. Then the ionic compounds, the charge on the each ion is used to determine the chemical formula of the compound. Okay. What is the answer to this question, everyone? Read it carefully. Come on, everyone. Answer this. Read it carefully. The careful reading is the answer. The careful reading will give you the answer. Come on, yaar, tell me. Only a few people are replying. Rest all. What happened? Answer this. All right, so not many people have answered. Let us check the answer. This one, guys, the right answer, that is option number B. An atom is the smallest particle of an element or a compound. Come on, is the smallest particle of a compound, is the smallest particle an atom? No, a compound's smallest particle is a molecule, not an atom. Remember that. Okay. Right, everyone. So I hope it is done. Huh. So this is the answer. Now moving further, let us see the different models. Guys, as far as the different models are concerned, you just need to read exactly as much as it is given here. Only that much. John Dalton presented the atom solid core model. Solid core model means what? Basically, this is the atom which is non-separable, which is non-breakable, indivisible, okay? And there are no subatomic particles. This is the hypothesis or postulate of the scholar called John Dalton. Then we have J.J. Thomson. J.J. Thomson was the one who discovered electrons. Okay, electrons. Guys, who discovered electrons, neutrons, etc.? That is also asked. So, if we talk about electrons, or we talk about alpha particles, or we talk about, you can say, Chadwick, who discovered neutrons. So, these are again very important things. Okay, very, very important things. Now, so Thomson actually discovered the electrons, and he gave the plum pudding model. What is plum pudding model? Guys, you can also call it as the watermelon model. Let me show you the picture of the Thomson's watermelon model. Okay, just a minute. Come on, man, this is such a ridiculous thing. Okay. So, plum pudding model of an atom. Okay. Guys, this is the plum pudding model. Okay, this is the plum pudding model. And you can actually check this plum pudding model like this. Okay. So guys, this is exactly what reflects the right. Okay. So this is your plum pudding model. Exactly, in fact, much better represented by a watermelon. So you can see this red paste, the red part is actually the positive charge, which is spreaded throughout. And then eventually we have the spreaded electrons as well. So that gives you the plum pudding model of Thomson. Okay. However, Thomson was actually, able to show one thing, that electrons are something which carry the negative charge for the first time, something that carried the charges, or for the first time something as a subatomic particle, that was also mentioned, that was also discovered by Thomson. Okay. Then guide, after that we have the Rutherford model. Rutherford actually told you that, usually whatever positive charge we have, Thomson said that the entire cloud of positive charge was there, and then we had the embedded negative charges here and there. But Rutherford said that no, most of the space is empty. It is the nucleus. It is the nucleus which has the dense positive charge. The rest of the place is empty, and then we have the negative charges. Okay, remember that. So here the same model was actually rearranged by Niels Bohr. Bohr's atomic model gave the concept of the energy orbits or the planetary model. So it said that the electrons, they move they moves around the positively charged nucleus, and they move like planets, which means that they move in a fixed orbit of the fixed energy. In case any electron is going on the outer orbit, it means it is gaining energy. As it will lose energy, it will move closer to the positive nucleus. So guys, this was the Bohr's atomic model, which was quite popular for many years. However, if we take it that that is the moving electrons should emit the energy and collapse into the nucleus. That was the question which was asked. So he just said, without any explanation, he simply said that let us assume that the energy level of each orbit is fixed and the energy of each molecule is fixed in its orbit level. So that was not a very satisfactory explanation, and it was rejected. All these four were rejected. Then guys, the quantum model came up by Erwin Schrödinger, who said that electrons do not move in any set path around the nucleus, but in the waves. So it is very, very difficult to exactly find out the position of the electrons. However, there are the clouds of high probability, the chances where the electrons could be found. There are some areas which are the high probability areas. So guys, this is how we can say the Schrödinger's atomic model as the most accurate atomic model was established. Okay, so these are some names which you need to remember or recall. Okay, now guys, we have the valency. What is valency, by the way? Valency means what? Valency is actually, as per the Bohr atomic model, the atom has the electrons around its nucleus. These electrons are arranged in the shells, in the different shells, okay, different orbits, remember? And if the 8 electron is there in outermost shell or outermost orbit, then it becomes the inert element, okay, which means that in order to have the complete orbit, the outermost orbit should have the 8. Like suppose this is the outermost orbit, this has to be 8. Okay, if this is not 8, this means what? This means then highly active. Why is that highly active or highly reactive rather? Because just to fulfill that octet, suppose if there is some element like say sodium has atomic number just 10, right? Sorry, 11, I'm sorry, just 11. The 11 atomic number, that means 2, 8 and 1. Only 1 is left, okay, which means that what? Which means that that one single electron will be pushing the conductivity and all of this particular element. Now, apart from that, The combining capacity, the tendency of the atoms to react and form molecules with this atoms is explained by their desire to achieve a fully fledged outermost cell. So basically, guys, outermost cells are the ones which take part in any kind of chemical reactions, and the outermost cells are the ones who which are actually supposed to be filled with the 8 electrons. Okay, with the 8 electrons. Now there are two types of valency, electrovalency and covalency. Guys, electrovalency is where there is the complete loss of one or more electrons. Okay, one or more electrons are completely lost, and then they might be gained as well if it is greater than 4. Okay, that is your electrovalency. So that helps in the formation of which bond? Ionic bond. Covalency is the formulation of the covalent bond where the electrons are shared. Shared collectively. Okay. So guys, in the ionic bond, you saw that sodium and chlorine, sodium chloride, this 2 bond, that is your bond. Okay. This is shared. This is shared. Then guys, we have the atomic number and the mass number. Now what is that? Atomic number and mass number. So you can see this one. Basically, any element is represented by this symbol X, where the Z or the Z is the atomic number. Atomic number is the number of protons, and mass number is the number of protons plus neutrons. Remember that. Usually we have number of protons is equal to number of electrons. Number of electrons. Remember that. So guys, when we talk about the mass number, mass of an atom is equal to proton plus neutron. Okay, proton plus neutron. Got it? And as the mass number is variable, but the atomic number is fixed. Atomic number is fixed. Therefore, you can see that the number of neutrons can also vary. Number of neutrons can also vary, and mass can also vary. Okay. For example, this is oxygen. Atomic number is 8. That is fixed. That is fixed. 8 is also the number of protons. That is number of protons. Then the mass is 16. Mass is 16, right? So which basically means the protons plus neutrons. So 16 is equal to number of protons 8 plus neutron. So this oxygen will have 8 neutron and 8 proton, right? 8 neutron and 8 proton. But my dear, there are certain variances as well, certain variations. For example, which one? Suppose if the atomic number is same, but the mass numbers are different. So my dear, isn't it very simple, very, very common to understand that if the atomic number is same, which means that protons, right, protons, say proton is equal to same, right? If Z1 is equal to Z2, then Proton 1 is equal to proton 2. Got it, everybody? However, if we talk about the mass number is different. A1 is not equals to A2. Mass number is different. Then what happens, my dear? Then you can see that. In such case, number of neutrons is equal to different. Okay, that is different. So guys, for example, hydrogen, you can see that hydrogen, it has deuterium, tritium, and protium. Okay, each of them have atomic number 1, but mass number is 1, 2, and 3. Like for example, this is the atomic number 1, which means the proton is there, electron is there, and no neutron is there. But deuterium, it means 1 proton, 1 neutron, and electron is there. Then we have the tritium. Tritium is 1 proton, 2 neutron, and electron is 1. Okay, everybody? So you can see that each of the isotope is a pure substance. It is a pure substance. Remember that. So I hope everyone understood the meaning of isotopes. Everybody, isotopes, for example, C12, okay, C12 and C14. C12 and C14. What are these? These are isotopes. How can you say that? For example, here C12 is the 12 is the mass number of carbon, 14 is the mass number of carbon. C12 means C12 is equal to 6 protons plus 6 neutrons. C14 is equal to 6 protons plus 8 neutrons. Okay, 8 neutrons. Remember, protons is same, but neutrons different, which means isotope. Then we have the isobars, which means that atomic numbers might be different, but the mass number is same. Mass number is same. For example, suppose you have the calcium, okay, and argon. Calcium is equal to, atomic number is equal to 20. Argon, okay, atomic number is equal to 18. Okay, but if you want them to have the same mass number, then what will be required? What will be required, my dear? Suppose plus 20 plus 22. Okay, is equal to that. So guys, this is what we have to consider. This is the calcium and argon, and that is your atomic number, right? So you can see that different atomic numbers. Okay, everybody, and you have the same mass numbers. Okay. Then guys, chemical equations are there. We can, not required. This is not required. Types of chemical reactions. Just the simple definitions are required. Combination reaction means what? Means where the multiple reactants combine to form a single product. Like we can see that the calcium oxide plus water, they react together to form the calcium hydroxide. Any kind of example could be taken. Multiple reactants combine together to form a single product, nothing else. Okay, remember that. Then there is the decomposition reaction, where one particular reactant is there which breaks down into the simpler products. Like for example, everyone, a carbohydrate, a long piece of sugar actually breaks down to give the simpler products or simpler sugars like sucrose, like fructose and like glucose, etc., etc. Okay. Then guys, CaO or calcium oxide, that is very, very useful. Again, silver chloride. Silver chloride is again a useful example of the decomposition reaction which turns gray in the sunlight because it undergoes decomposition. Okay. Then guys, combination reaction. After that, we had the decomposition reaction. Then we have the displacement reactions. What is the displacement reaction? Suppose two different kind of compounds are reacting with each other and one contains such an atom or such a molecule which will replace the other atom or molecule for sure. Like iron is added to the copper sulfate solution, so that becomes iron sulfate. Okay, that becomes iron sulfate. Copper sulfate is basically now iron sulfate because iron is far more reactive than the copper, hence iron is more reactive, copper is less. Okay. Then guys, oxidation and reduction. What is that? Removal of oxygen from a substance or adding up the hydrogen, that is called reduction. And adding up the hydrogen and removal, adding up the oxygen and removal of the hydrogen, that is called oxidation. That is called oxidation. Remember that. So these both activities take place side by side. Okay. Then guys, we have the rancidity. What is rancidity? Rancidity is something where the oil and especially the fats, etc., when it is used in cooking or when it is used in the deep frying, etc., after some times that oil becomes very bad and very foul smelling thing, very unpleasant kind of taste. So guys, that is your rancidity. What happens here? Actually, the oils and fatty acids undergo the what do we call as undergo the oxidation, right? Oxidation, and that oxidation actually leads to the formation of the several products and at the same time several chemicals which are very smelly and very I would say unpleasant in the taste as well. Okay. So guys, this is basically the rancidity, or rancidity is actually expressed by the common people, common trends. Now guys, can we prevent or retard the rancidity? So yes, we can actually do that. For example, by adding the butylated hydroxyanisole, okay, or simply packaging the oil and salt, etc., in the nitrogen gas. That will also save you from the smells of rancidity. It's very foul and very ugly smelling. Answer please this question. Right? Answer please, everyone. Which of the following is the cause of corrosion of the metals and rancidity of the food? Yes, everybody, very simple. Rancidity of the food as well as the corrosion of the metals, they are both caused by the same thing. Caused by the same thing. Exactly. Very good. Oxidation reaction. Very nice. Then consider the following statements. Diamond is an allotrope of carbon. Mercury is a metal that is liquid at the room temperature. Which of the statements given above are correct? Yes, everyone? Tell me. Yes, everybody. So, absolutely good. Both of them. So, mercury is a metal that is liquid at the room temperature. Correct. Diamond is an allotrope of the carbon. Correct. What is allotrope, my dear? Allotrope means something, right, which has all the same number of atoms but different pattern of arrangement. Carbon, graphite, etc. Okay, carbon, graphite, diamond. Okay, all these. Okay. Okay, everyone. So that is all in today's session. So tomorrow will be probably an off day. Let me just check if tomorrow is an off day or not. Tomorrow will be an off day. Yes, tomorrow will be an off day. And tomorrow is the Independence Day of our country, our beloved country. So wish you all a very happy Independence Day, guys, for tomorrow. And just be your best and celebrate with whole heart tomorrow, and completely it should be a very amazing, very, very tremendous Independence Day for all of you tomorrow. See you in the next class day after. Okay, thank you so much, everyone. Bye bye. Jai Hind.